In this video, I'm going to teach you how to find prime factorization using factor trees and factor pairs using factor rainbows. Let's begin with prime factorization. You take a number like 48 and you split it into smaller pieces. What times what equals 48? You could do 6 times 8. You could do 12 by 4, and either one would get you the same answer. Let's examine 48 with 6 and 8. We can break 6 down to 3 times 2 and 8 down to 4 times 2. 3 is prime, so we circle it. It's on your sieve of Eratosthenes. 2 is also prime. 4 is not, so it has to keep going. 2 times 2 is 4. And so it breaks down into 2 2s. This is also prime, so we can write this on a line, and then we can put it least to greatest and put it in exponential form. So this is 3 times 2 times 2 times 2 times 2. Make sure that you get all your factors, whether they're up here, or down here, or up here. You need all of those. And then you need to put it least to greatest in an exponential form. So this would be 2 times 2 times 2 times 2, so that's 2 to the 4th power, times, we use a dot, 3. And that is prime factorization using a factor tree. Now let's examine what happens if we broke it down differently. This one we broke down into 12 times 4, which, as we know, also equals 48. Will it turn out the same? Let's find out. So 12 is not prime. It would break down into, let's say, 4 times 3. We could also do 6 times 2. 4 is not prime. It would break down into 2 times 2. 3 is prime. 2 is prime. 3 is prime. Circle those. 4 would keep going into 2 times 2. Circle them all. Now, notice that we still have 1 3 and 1 2 3 4 2s. So we would again have 1 3, and we would have 2 to the 4th power. Now I went straight to least to greatest and exponential form with that, but they are equal. Let's do one more like that before we talk about factor rainbows. Let's take the number 80. We could break that down into 8 times 10, or we could break it down into 4 times 20, or 40 times 2. Lots of different ways. Let's go with my first suggestion of 8 times 10. That's not prime. 8 isn't, and neither is 10, so they keep going. 8 breaks down to 2 times 4. 2 is prime, 4 is not. 4 breaks down into 2 times 2. Those are both prime. 10 breaks down into 2 times 5. 2 is prime, so is 5. They're both on your sieve of Eratosthenes. So now let's put this into a line, and that's going to be the prime factorization. So this says 2 times 2 times 2 times 2 times 5. Again, making sure that you get all of your factors, whether they're up or down, a little lower or a little higher. As long as they're circled, we need them. Making this least to greatest. Oh, it's already least to greatest, so that was lucky. Now we need exponents. That means 2 to the 4th power times 5. Okay, now let's talk about the other topic up here, which was factor pairs, and we use factor rainbows to find those. This would be like the number, I'll pick a hard one, 24. Okay, if we want to know all the pairs of factors in 24, we're always going to start with 1 in that number. So 1 in 24. Then we say, is it even? Yes, it's even because it ends in an even number. 0, 2, 4, 6, or 8. So the pair with 2 would be 12. So I'm trying to, I'm going to cut these real quick, put them down a little farther so I'll have room for my rainbow. If you know what I'm talking about, you feel me. Okay, now 3 also goes into 24 8 times, 4 goes into 24 6 times, and 5 doesn't work. So we know we're done because 4 and 6 only have a 5 in between it. Connect your pairs, and you're making a rainbow. That's a factor rainbow, and those are factor pairs. Let's try one more example of those. And then you would just list them on your paper like 1, 2, 3, 4, 6, 8, 12, and 24. But this is a method where you never miss the other pair because you're always connecting it with a rainbow. So you know you didn't miss the 8 because you knew 3 had to connect to something. You didn't miss the 12 because you knew 2 had to connect to something. All right, one more. Let's try 40. 40 doesn't have too many, but enough to do. Oops, you know what, I'm gonna give myself more room. 1 and 40. We know it's even, so 2 goes in 20 times. 3 does not. So we think in our head about 3, we take it away because it doesn't. Then 4 goes in how many times? You should be saying 10. Oh, 5 goes in also. How many times? 8. And there's no 6 and no 7, which means we're done with 8. We get back to the other side. And let's make our arches for our rainbow. And so there's our factor pairs. If they just said list the factors, we would write 1, 2, whoops, not 3, 4, 5, 8, 10, 20, 40. Make sure that you have the right number. 1, 2, 3, 4 on this side, which means I need 4 on that side, which means 8 total. 1, 2, 3, 4, 5, 6, 7, 8. Very good. And we're done. Make sure to ask lots of questions in class and watch again and again if you need to.